a wonderful day. Welcome you for this presentation. Now we will be discussing the continuation of equilibrium of concurrent and non-concurrent coplanar force system. And further, there is a different type of problem which we have to deal, and it is a branch. Regarding this, there are set of problems. In the earlier session, we have identified that. So what are the cable and rope oriented problems? And now we will be discussing sphere oriented problems. A sphere weighing 100 Newton is fitted in a right angle notch as shown in figure. Okay, so this is a sphere and this is the notch which is a right angle, and hence it is a right angle, it will be 90 degree inside the notch, and outside that they have given the angle as 30 degree and 60 degree at the point A and B. So this sphere is being supported by, if all the contact surfaces are smooth, determine the reaction at contact surfaces. So you have to find the reaction. So the sphere has a self weight of 100 Newton and it will be acting at downward direction. Let us take all the force from a point. From the center point, you will be having a 100 kilonewton force. If the force is here, that is RA, and throughout the line of force, so this is known as transmissibility, and if RA is here along the line of the action of force, the force will be same. So you can write it as RA, which is acting at 30 degree. So how we have found out the 30 and 60 degree? So let us see that. Let us take only this surface. So RA surface we are considering, and you have 60 degree angle here with respect to the reaction. So there is a force reaction action. So if a support is there at A, so there will be a force due to the sphere. So the sphere has self weight, so there will be a force and a reaction. So the reaction is RA and the force is here, which is written as RA. So both will be equal and opposite. Okay. So let us make a horizontal line here, and we know that this is the force and this is the reaction. Both are equal and opposite. So if you identify the reaction, you can identify the force. Okay. We know that if this is 60 degree with respect to horizontal, at the same point you will be having 60 degree with the horizontal. So surface will be at the same angle. So we know that the opposite angle will also be same. So this will also be a 60 degree angle. Since we know that the load is acting perpendicular to the plane, so this will be 90 degree. So if you subtract 60 degree, you will be getting the angle 30 degree with respect to horizontal. So this is what in simple it is written here. So the same force which is being transferred to the point. Okay, and let us take the next reaction, that is RB, and let us draw a straight line here, and if you draw a line there will be force and a reaction, and let us take this as RB. Yes, after drawing this horizontal line, we know that this is the same angle, that is 30 degree. The opposite angle will also be a 30 degree. Since the load is perpendicular to the surface, and 90 minus 30 will be 60 degree angle. So this is what we have written here. RB is 60 degree from the horizontal. Yes. So if you have found out, so one is a weight component, that is self weight, and other two are the support reaction. Okay, we have drawn into a free body diagram, and we can simplify by using Lamy's theorem. So we have three forces and all the angles are known. Since this is 60 degree, the remaining angle will be 30, and if this is 30 degree, the rest of the angle will be 60. So all the angles are known here, and let us apply by using Lamy's theorem and find these reactions, that is RA and RB. So RB sin 120 degree and RA sin 150 degree equal to 100 divided by sin 90 degree. So this will be the angle on all the Lamy's component. First we will find RB. RB equal to 100 into sin 120 degree divided by sin 90. So if you simplify, you will be getting 86.6 602 Newton. If you need RA, you can cross multiply and find RA. So you will be getting RA as 50 Newton. When you looking into a problem, it saw that there are number of unknowns here. But if you keenly look into the components, that is force and reaction component, you can identify how much the surface has to support. So the RA support has to bear a load of 50 Newton and RB support has to bear a load of 86.6 Newton. So due to the 100 Newton of weight, you can see that even though it is touching in a surface, this surface does not take the same amount of force. So we may think that generally, so if the load is acting, that is 100 kilonewton load is acting, each will be taking 50 kilonewton, 50 kilonewton. The concept of mathematics and the alignment of this load, the reaction changes. Yes, let us go to the next problem. Find the reaction from the inclined plane and tension in the string for the arrangement in figure. And a figure is shown here and a string is being attached. So the string has an angle of 70 degree, and with the string you have the sphere which is supported at the frame. So this is the frame. You have an angle of the frame as 40 degree, and this is the arrangement of the sphere. You have to find the reaction. There will be three number of reaction. Since this is a sphere, it is having a self weight. So the weight of the ball is 450 Newton, and weight always acts at the direction of gravity. So hence the weight acts 450 Newton in vertical downward, and you have a string which is having a 70 degree angle, and if you introduce a vertical line here, so the 70 degree will be same here with respect to the horizontal. So both will be same here, and hence T is written here and the angle is 70. Okay. So when finding the reaction, that is R with respect to the frame here, you have 40 degree. Let us follow the same procedure. Let us draw a horizontal line. So you know that this angle is 40 degree and the opposite angle will be for 40 degree, and we can find the rest of the angle which is 50 degree. Since it is a straight line, so due to this transmissibility, a force or a reaction can transmit into an object with the same intensity. The rest of the angle will be 50 degree with respect to horizontal. Hence we have written it as 50 degree with respect to horizontal. So we know the three number of forces and the angles are known. If this is 50 degree, the rest of the thing will be 40, and 90 minus 70 will be 20 degree. Okay, so we have identified all the components, and let us use Lamy's theorem in order to find the tension and the reaction. So T divided by 140, T by 140 is here, and R by 160. So R divided by sine 160, 90 plus 70, and 450 divided by sine 60 degree. 450, 40 plus 20 will be 60. So if you need T and R, you can find it separately. If you need T, 450 into sine 140 divided by sine 60. And if you need R, you can take 450 by sine 60 into sine 160 degree. And the R and T is found here. T will be 334.02 Newton and R will be 177.719 Newton. Yes, let us take a next problem. And a horizontal shaft with inner clearance of 1000 meter carries a two sphere of radius 350 mm and 250 mm as shown in the figure. If you have the radius, so the radius is 350 and the remaining distance will be 350. So totally 700 mm distance, and the smaller here will be having 250 mm radius and other will be 250, so totally 500. So 700 plus 500 will be 1200. So if you fit into a box, so it will not fit exactly. So due to the clearance limit, so you have only 1000 mm and your sphere total distance has 1200 mm. Let us find the support reaction. For the sphere 1, you will be having a support reaction of RC and RD, and the third reaction will be RB. So there is a support and a force due to the smaller sphere, and there are two forces which is acting from the box. Also, if you consider the smaller sphere, you will be having a reaction of RA and RB along with its self weight. Both the sphere have the self weight. So let us solve this. So we know that there are only limited number of reactions, that is RA, RB and weight. So there are three number of reactions. So let us take this small sphere and solve by using Lamy's theorem. And this will be RA from this support, and this is the first reaction, and second reaction will be RB. Since you know the radius of the sphere, so you can add. So 350 plus 250 will be the radius. If you add that, 350 plus 250 will be total diagonal distance. So the center to center distance between the center of both the masses is P and Q, which is 600 mm distance. If you add 350 and 250, you will be getting the total distance. If you subtract from this 1000, so we have 1000 mm distance. So if you subtract 350 and 250 is second sphere's radius, and we will be getting R as 400 mm. So P and R is 400. We can find Q and R. Let us use cos theta here, the adjacent side by hypotenuse. So for cos theta, that is adjacent side is PR and opposite side is PQ. So PR by PQ, 400 by 600 equal to 48.18 degree. And we have applied and we have found out the theta. So you can cross multiply. So you can take cos outside this equation and find the theta. So the theta will be 48.18 degree. We have found out the angle here. The RB, which will be in an angle with respective to the horizontal, as 48.18 degree. Yes, for this we have identified the angle. Okay. So next, the third component will be the weight, self weight. Self weight will be 500 Newton, and these are the three components of this sphere. Okay, let us make all the force which is acting in a point. So what we will be doing is, so there is a reaction RB here. So let us take this reaction with respect to horizontal plane. So this angle will be 48.18 degree. So if this load crosses the same line, so along this line with respect to horizontal, it will be 48.18 degree. Hence we have written here as 48.18 degree, and the rest of the angle will be 41.82. Okay, we have found out RB here, and RA is acting at the horizontal direction, which is purely horizontal, and you can take it as the same force. And we have got all the three angles of this force. Lamy's theorem, 500 divided by the opposite angle will be 90 plus 41.82, so which will be 131.82. So 500 divided by sine 131.82 degree, and RA divided by sine 138.18 degree, and RB, the opposite angle, will be sine 90 degree. So RB sine 90 degree. So you can find easily RB and RA by cross multiplying the sine value. You will be getting 447.365 Newton and RB as 670.922 Newton. The sphere 2 has more force at the point B. So RB is 670 nearly, and RA is 447. You can see that there is more force which is acting at the support B. Okay, let us consider the second sphere. So this will be the second sphere. We already know that the angle which is created is 48.18 degree, and you have another force here, that is RC. So along this plane you will be having the same force, and it is purely acting in horizontal direction. So next, the self weight, which is 600 Newton. So the 600 Newton self weight is acting downward, and you have a reaction which is purely acting at horizontal direction. Hence RC is acting at right hand side, which purely horizontal. The next force is RB here, and RB is acting at an angle of 48.18 degree. So we know this angle. So if you take this force into the opposite direction, you will be having the same 48.18 degree here. Hence we have taken the RB as 48.18 degree with respect to horizontal, and we know the reaction here. So the reaction due to RB is 670.992, which we have found earlier. Last reaction is RD. So RD is acting upward. So you can take, this is a purely upward acting force. You can take RD. And what are the unknowns here? RD and RC has to be found. So RB is already been found out, and you can use, since you are having 4 number of forces, and we cannot use the Lamy's theorem here, hence we have to use the law of equilibrium, that is summation of f of x equal to 0 and summation of f of y. So we have to resolve all the forces vertically and horizontally. So if you resolve horizontally, sum of f of x equal to 0, let us resolve all the forces with respect to horizontal axis. So 670.992 cos 48.18 degree. This is written here, and you are having a force of RC. So plus RC. So this will be minus, and the RC will be plus, equal to 0. So if you want to find RC, you can take it outside and find RC. So it is 447.366 Newton. And let us resolve vertically, sum of f of y equal to 0, and if you resolve 670.992 sin 48.18 degree, so you can resolve, it will be acting in downward direction, hence it is minus. So the component is here, and you are having minus 600, it is written here, and you are having an upward force of RD, plus RD. So plus RD is written here. You can take everything outside, and RD will be 1100 Newton. We have found out all the reactions. So that is RC, RD, RB and RA. All the reaction forces being found out. And we found that the largest support reaction, which is RD here. So this is something to understand. This larger sphere has to support some of the reaction from RB, and also it has to take the self weight. Hence we can see that 1100 Newton of reaction forces acting at RD. The next problem, two identical rollers which each weight 400 Newton are placed in a trench as shown in figure. Assume that all the contact surfaces are smooth. So why they are mentioning here is there is no friction between the load and the support, and determine the reaction at the contact point A, B, C and D. So there is a trench here which is indicated, and the angle of the trench is 30 degree. You have the total number of support, that is, this is at the point A, and point B is the meeting point, and point C and D is the surface of the trench. We have to find all the support reactions. Let us first identify the free body diagram in order to identify the reaction. Okay, let us take the sphere 2. Why? Because there will be less number of reactions, so it will be easy to analyze. And if you are taking sphere 2, you are having two number of reactions, that is RA and RB. We know that a self weight is acting, which is 400, and a reaction force which is at RB. So we have to find the angle of RA and RB. We know that the concept, we have to just introduce a horizontal line. So if you have a plane here which is having a 30 degree, if you draw a horizontal line, the opposite angle will be the same 30 degree, and with respect to this horizontal angle, you will be having a 30 degree here. And if you want to find RA, we will be knowing that this angle will be 30, hence the opposite angle will also be 30 degree, and the remaining angle will be 60 degree. respective to horizontal axis, you will be having 60 degree of an angle. RB will be 30 degree with respect to horizontal axis. Okay, after finding this, so if you subtract 180 minus 90, you will be getting exactly 90 degree angle, and the remaining angles we shall find. 90 plus 60 will be, total angle will be 150, and 90 plus 30, you will be having a total angle of 120 degree. So you can use Lamy's theorem in order to find the reactions, and 400 divided by sine 90 degree, RA divided by sine 120 degree, and RB divided by sine 150 degree. So this is the Lamy's equation. You can find RB and RA. After simplifying, you got 200 Newton and 346.410 Newton. Okay. So let us find the reactions at the sphere 1. So we have number of support here, that is B, D and C. So RB is already known here, hence it is written as 200 Newton, which is already identified. And the angle we are knowing that with respect to horizontal degree is 30. The RB is acting with respect to horizontal axis is 30 degree here. So this angle will be 60 degree. Next, there will be a force which is the self weight 400 Newton, which is acting downward, and 400 Newton is written here. And you are having RD, which is acting purely at horizontal axis, and you can take RD as horizontal. Okay. We found that this angle as 60 degree here. Since we are having 4 number of forces, we can use the equilibrium equations in order to find the remaining reactions. To resolve all the forces vertically, minus 400, and this will be acting downward, hence it is minus 400, and 200 sine 30 degree, minus 200 sine 30 degree, which is acting downward, and plus RC into sine 60 degree, plus RC into sine 60. If you resolve this and simplify, which is 577.805 Newton, and when we resolve horizontally, you will be having minus 200 cos 30 degree, minus 200 cos 30 degree, and minus RC into cos 60 degree, minus RC cos 60 is written here, and RD is acting right hand side, hence it is plus. So you know RB value, which is 200, and RC value is 577.850, and the only unknown is RD here. So you can take RD outside, and you will find 461.88 Newton as RD. And we have found out the reaction component of RC, RD and RB. Okay, let us take the next example. Determine the reaction at contact point for the sphere ABC as shown in figure. It is given that, so the list of data is given here, and in this problem you have 3 number of sphere, that is a larger sphere which is having a diameter of 600 mm, and 2 small sphere which is having a AB, and the weight WA and WB is 4 kilonewton. Both are smaller weight, which is 4, and the larger one is 6 kilonewton. Yes, so you know the concept. First you have to draw the support reaction which is acting towards the sphere. So this is the procedure. If you consider sphere C, you will be having 2 contact points, that is at K and L. So these are the 2 contact point, and you will be having a self weight. So first we will solve the mechanics at the point C, then we shall go to sphere A and sphere B. So at sphere A you will be having a contact point at P and O, and at B you will be having a contact point of M and N. So these are the number of contact point you have to identify. So you are having a diameter of 800 for the sphere C, and 500 for the sphere A, and 500 for the sphere B. Okay, all the diameter is given here, and what we can do is, let us find the angle of the contact point. So you know the diameter is 800, so the radius will be 400 mm, and this sphere diameter is 500 mm and the radius will be 250 mm. If you add both the radius, that is the radius of sphere A and radius of sphere C. So this is 250 and 400. So if you add that, you will be getting 650. So this will be the distance between the center of point A and point C. The distance between the two spheres between A and B is given as 600 mm. So the center will be acting exactly at 300 mm. So we have a triangle here. You know the two sides, that is AD and AC. So we can use cos theta, that is adjacent side by hypotenuse, in order to find the angle. So if you apply that, 300 by 650, so theta will be 62.51. So you have found out the angle. Also there is an angle with the two surface. So for the sphere A, you are having a surface of 75-degree angle, and for the sphere B, you are having an angle of 65 degree. Okay. With this given data, let us find the reactions. So let us take one by one and let us resolve. So we will be taking the first sphere, that is C sphere, and let us find the reaction at K and L. So by the experience of the previous problem, let us try to imagine and understand the support reaction. We will be having a reaction of K here, and the angle with respect to horizontal axis is, we have already found out, as 62.51 degree. So if you drop a horizontal line, the same line of action of force will be there. So you will be getting the same angle for 62.51 for the RK. And also, since it is a same triangle which is there at C, B and D, so the distance is same, that is base is 300 and the diagonal is 650. So you will be having the same angle, hence RL will be the line of action. So along this line of action, with respect to horizontal, you will be having the same 62.51 degree, and the rest of the angle you can find. So 90 minus 62.51 will be 27.49 degree. So the same angle will be here at this quadrant. Okay. After identifying this, you can use the Lamy's theorem. You can find RK and RL. Okay, so 6 divided by sine, you have to plus both the angle, so it will be 54.98, and RK divided by sine 90 plus 62.51, it will be 152.51. So for RL, the angle will be same, and RK and RL will be same. If you multiply, sine 152.51 degree, value is 3.382 kilonewton. So we have found out for the sphere C. Okay, let us go to the next sphere. Take the sphere B, and if we are finding the reactions, so the reaction at Rm, Rn will be upward. So since we know that the reaction will be upward purely, and Rn is written here, and the self weight which will be acting at downward, which is 4 kilonewton, and the angle with Rm will be 65 degree. So you will be getting Rm as the same 65 degree angle, and the next force is RL. So you already found out that the line of action of force is RL, and the angle is 62.51 degree, and the same angle will be here for the RL. So with respect to horizontal, the angle will be 62.51 degree. So in this problem we have to imagine. So the concept are given in the previous problem. The same way you can improve your understanding ability. So this will be your exercise, and you can solve by using the major requirements of a problem. The RL, we have already found that the angle here is 62.51 degree. So if you put a horizontal line here, the same angle will be here at all the line of action. So the angle will be 62.51 degree. Yes, now resolving this problem. So first we shall resolve all the forces horizontally. So you have RL cos 62.51 degree. So this will be plus. So RL plus cos 62.51 degree, and RM with respect to horizontal. So you know that this is 65 degree and the rest of the angle will be 25 degree, and RM cos 25 degree, which will be minus. Okay. Next let us find the RM. Since RL we have already found out as 3.382, you can substitute as RL and it will be 1.722 kilonewton. Okay. So let us resolve vertically. Plus Rn is written here and the minus 4 kilonewton which is acting, and minus 4 is written here, and if you resolve RL with respect to vertical, RL sin 62.51 degree, which will be negative. So it is written here, and also RM sin 25 degree, which is upward. So RM sin 25 degree. So you know the answer of RM, you can substitute, and RL is also known, you can substitute here, and only one unknown is Rn, hence you can take rest of the things outside this equation and you can find Rn, which is 6.272 kilonewton. Okay, now let us take the last sphere, which is A. So if you are taking the sphere A, you have the contact point of RK, which is known, the horizontal angle as 62.15 degree, the opposite angle will be the same, and hence it is written as 62.51 degree. Next let us take the reaction of RP here. Since the support reaction which is not horizontal, it is at an angle of 75 degree, you will be having the same 75 degree here. So if you drop a horizontal line, the angle will be same. So if you subtract 75 degree here, you will be getting the rest of the angle is 15 degree. So it is written here. So RP will be acting, if you project this line at the point A, you will be having the same equal and opposite angle at the point. Now we have found out RP as 15 degree with respect to the horizontal axis. So you know the RO is support reaction which will be acting at the point O and which will be upward, and you have 4 kilonewton force which is acting downward. Okay, so we know all the angles and the forces, so you can multiply. So you can use equations of equilibrium in order to solve. So let us use sum of all the horizontal forces as 0, and if you resolve horizontally, RP into cos 15 degree, which will be acting right hand side, and plus RP into cos 15 degree, and you have RK which is at an angle of 62.51 degree, which is minus RK cos 62.51 degree. So the rest of the forces are acting purely vertical. Okay, hence if you resolve this equal to 0, so since we know RK as 3.382 which we have found earlier, and you can divide this by cos 15 degree and you will be getting RP as 1.616 Newton, and if you resolve vertically, minus RK sin 62.51 degree and minus RK sin 62.51 degree, and you have 4 kilonewton which is acting downward, minus 4, and RO is acting upward, so it is plus RO, and RP this sin 15 degree and RP sin 15 degree which will be acting upward after resolving. And if you need RO, you can substitute RP, we have found out earlier, and RK which is known, which is 3.382, you can substitute this and you can take everything outside this equation in order to find RO. Now we have found out as, if you simplify, you will be getting 6.582 kilonewton. Yes, so we have found all the support reactions of this problem. Okay, these are the series of problem which is having a sphere oriented equilibrium concept problem. A sphere will be dropped at each and every conditions of the support. So what you have to do is, you have to find the support. How many supports are there? How many forces are acting in an object? So you are having P, O and K here. So these are the points of contact, and for each and every contact you have made it as a reaction along with its self weight. Always you will be having a self weight of an object. So you have to consider the self weight of the object and the surface point of contact, whatever might be the object, you have to consider. And the thing is, if you have a strong geometry concept, the geometric property of lines and angles, so it will be easy to identify the angle of the force and angle of the horizontal axis. So if you know to find this, you can use either Lamy's theorem or you can use equilibrium equation in order to find the support reaction. So this series of examples help you to understand the sphere oriented concept, to identify and to solve, to find the reactions. Why we are here using equilibrium equation is, so after dropping this object, the object is under rest. Hence you can use the above concept in order to find the requirement. Yes, I hope that you have got the concept. See you soon. Happy learning. See you again. Thank you.